In this video, we're going to take some time to prove Rolle's theorem. So what does Rolle's theorem say? It says if f is a continuous function on a closed interval from a to b that is differentiable on that open interval from a to b, and the function values at the two endpoints at a and b are equal, then there has to be some point on the interior in the open interval from a to b that has the derivative equal to 0. All right, so let's take some time to prove this. So since we know that closed interval a to b, so it's closed and bounded, so it's compact. Since that is compact and f is continuous, and f is continuous on the open interval a to b by the extreme value theorem, then by the extreme value theorem, there exist points x1 and x2 in that closed interval a to b such that f has maximum and minimums at these values. Perfect. So we've established that it has to contain a maximum or minimum first. We established that by the extreme value theorem. So now we're going to consider two cases. And so our first case is what happens if the max and min both occur at the endpoints. So if x1 and x2 are a and b, then what do we know? All right, so here I'm not saying that a is the max and b is the min. I'm saying that one of them is the max, is the location of the maximum, and one of the values of a and b is the location of the minimum. All right, so this isn't necessarily respectively the max and min. But if we have the max occurring at one endpoint and the minimum occurring at the other endpoint, then what must be true about our function f? Well, f must be a constant because at one endpoint we have a maximum, at the other endpoint we have a minimum, so all the values and the two endpoints are equal, so all values must be equal. So f must be a constant on that closed interval a to b. And if we have a constant, then that derivative is equal to 0 for every single value in that closed interval. So we have points in the interior that have a derivative that's equal to 0. Case 2, is what we have otherwise. So if x1 and x2 are not both at the endpoint, so if we don't have the minimum at one endpoint and the maximum at the other, then the minimum or maximum, one of those two has to occur in the interior. So f is not constant. So f has either a min or a max at a point C in the open interval from A to B. But our previous theorem says if we have a minimum or maximum and we have a differentiable on an open interval and it's a differentiable function and it's continuous, but we have this differentiable function, then the derivative at that point has to be equal to 0. That's by our previous theorem. Which was right here. If f is differentiable on an open interval and it assumes it's maximum or minimum, then that derivative at that point has to be equal to 0. So theorem 6.2.1. And that proves Rolle's theorem. All right. Next time, we're going to take a look at the mean value theorem. All right, we'll see you there.